Example, they give you the coordinates and you have to identify what type of shape it is. Well, how would we know if it's a square? Without graphing it, how would you know if it's a square? We know that a square has all four sides that are equal. How could you figure out if the lengths of the shape are equal? What would you use to figure out the length of the line segment? Okay, so if we were to graph this, well, without graphing, if we find the length of line P to Q, let's say, and the length from Q to R, S to R, P to R, whatever, however you graph it, if all of the line segments were equal, what could that tell us? What could that be? What could be one clue that it could tell us? So if all the sides were equal, it's a possibility that it could be a square, right? If all four sides are equal. But what else has to happen with a square? What else do you have to look for? To see if the two lines, so if let's say this line and this line intersect at a 90-degree angle, how do you do that without graphing? How can you figure out if these two lines intersect at a right angle? What did we do last week? What would you have to look for? What would you have to find? We would have to find the slope of this line segment, and we'd have to find the slope of this line segment. And if they were what? How would you know if they were perpendicular? Right, if the slopes are negative reciprocals of one another. Okay, well, if all four sides were the same, it's possible it could be a square, right? Yeah. What other properties are there of a square? We just talked about it. Sides have to be perpendicular. What other shape has four equal sides? Okay, a rhombus also has four equal sides, but they do not intersect at a 90-degree angle. A rhombus does not have 90-degree angles in it, otherwise it would be a square. So just like in a square, opposite sides are parallel. Okay, this also occurs in a rhombus. The opposite sides are still parallel. It's basically just a square on a slant, right? Sorry, I drew that really bad. Rhombus is very similar to a square. The only difference is that it doesn't intersect at 90-degree angles. So algebraically, we have to figure out if the four sides are equal using what formula? Okay, good. We have to use the distance formula to find out the length of the line segments. We have to find the slopes of the line segments to see if they intersect at 90-degree angles. And in order to see if the opposite sides are parallel, we have to compare all the slopes. If the opposite side lengths have the same slope, it means it's parallel, right? So we have to see if the slopes are the same. Now is find the length from Q to R. Okay, so you're going to do Q and R, the length of that line segment, and Q and S. I meant to say R and S. Then another partner can find the length from P to S and the length from Q to P. We need to find out the length of these lines to figure out if they're all equal. Okay, so you're going to plug in the coordinates for Q and R into the distance formula to find out the length of that line segment. For the length of QR, it's 29.15 units long. When we use distance formula, we also get 29.15 for RF. Okay, so if we calculate the distance formula for each segment of the shape, we see that, so there's a possibility that this could be a square, and there's also a possibility that it could be a rhombus. We need to see if any of the slopes are negative reciprocals of each other. If they are, what shape is it? If it's a square. So let's start with PS, using the slope formula, y2 minus y1. So I'm going to do 10 take away negative 5 over negative 30 minus negative 5. And I get negative 15 over 25. Let's reduce all of these to lowest terms so we can compare it easier. Negative 3 over 5. I just found the slope for PS, which was negative 3 over 5 for PS. So the slope that I just found was actually, what was it, QP? PQ, QP. Let's label it on our diagram. Yes, sorry. I found the slope from Q to P is negative 3/5. Okay, and if you look at the graph, because we graphed this, that is the one that shows a negative slope. It's falling to the right. What is the slope for RS? Anyone find it yet? This has a slope of -3/5 as well. Okay, did anyone find the slopes of PS and QR? And looking at this graph, we know that this slope is positive, and when you calculate the slope, positive 3/5, what's the slope of QR? 3/5. What do you notice about the opposite line segments and their slopes? The opposite side lengths have the same slopes, which means that this line and this line are parallel, and these two lines are also parallel. How do I know that they're not going to intersect at a 90-degree angle from looking at the slope? The slopes are not negative reciprocals. They're opposites. One's positive, one's negative, but they're not reciprocals of each other. So they cannot be perpendicular, which means this cannot be what shape? It can't be a square. What shape is this? Rhombus. Okay, so to prove what type of shape this is, you have to prove it algebraically. You have to prove that the line segments are the same, and you have to prove that the sides don't intersect at 90-degree angles.
Made with Doodlecast Pro.